Okay, we are going to work on something called Euler's method, and what this is a numerical method for us to find solutions for differential equations. So now what we're going to focus on is a way for us to numerically calculate solutions. And this process is called Euler's method. Now all of this that we're going to do today is based on a very simple concept. This is all based on the fact that dy dx is going to be approximately equal to delta y over delta x. Now I want you to think about this. Delta y over delta x is what we usually refer to as slope, right? So we are going to use this approximation. Dy dx is approximately delta y over delta x if we have really small values that we're choosing to use. So basing everything on that, I actually do something little here. I multiply dx on both sides so that I have delta y is approximately dy dx times delta x. So this is our question. I want to use Euler's method to approximate the solution on the interval 0 to 2. So we're going to start with our initial condition of 0, 0. So we're going to fill out our table and say x is 0 and y is 0. Now the other piece of information that you're given is delta x. That means your increments for x. It's going to be 0.5. So that means I'm going to already know my next x value should be 0.5. The one after that will be 1.0. The one after that will be 1.5. And then I'm going to end with 2.0. Notice how that's the end of my interval a to b here. Now let's look over here on our graph. I want to basically approximate what the solution will be when x equals to 2. Now again, you know that this is a parabola. It's a pretty simple one, but let's assume that we didn't quite know that yet. So looking over here, let's just fill out this chart. We have an x-coordinate of 0, y-coordinate of 0. Delta y is equal to dy dx times delta x. Well, for this problem, this is our dy dx. So we're going to plug that into here. 2x, and my delta x is a 0.5. If you want to simplify this, you can, and that actually works out kind of nice. 2x times 0.5 is equal to x. So that means my delta y is always going to equal whatever my x-coordinate value is. So in this case, 0. My next y value will be 0 plus 0, so it's still 0. So my first coordinate point, if we take a look over here on the graph, my first point is 0, 0. My second point is 0, 5. So basically I'm drawing a tangent line from 0, 0, and I'm extending it over to the next x value. Now let's look at this next line. Okay, so delta y I know has been calculated to equal x. Well, on this line that I'm working on right now, what does x equal to? For this line right here, x equals to 0.5, so here my delta y equals to 0.5. What that means is over here in terms of our graph, as x moves over half, my y value is also going to go up half. So now it looks like this. And so my new y value is now 0.5. Then we do this one more time. Our delta y is equal to x, and on this line right here that we're working on, the x-coordinate is 1. So now from this point, if you look over on our graph, our y value has to go up 1 point as our x value goes up half a point. So it's over here. And looking on our table here, this should be 0.5 plus 1, so I'm now at 1.5. I can actually go over here and label this point. It's 0.5 comma 0. The second point is 1 comma 0.5. And my third point is 1.5 comma 1.5. Notice how it matches up with my table of values. Okay, let's do one more line here. Delta y is going to equal to, again, x, and my x value here is 1.5. So my new y value is going to be 3, because 1.5 plus 1.5 equals to 3. Notice how each of these coordinate points kind of looks like our parabola. Well, that's because I'm using the differential equation dy dx equals to 2x to model this. What we're looking for here as our answer is 3. Our approximation gives us f of 2.0 is approximately 3. I'm going to continue to use the same dy dx, but this time I'm going to make my increment a little bit smaller. Delta x is going to be 0.25, And I'm again going to start with my initial condition of 0, 0. Let's take a look. My increments for x are going to be 0.25, so my next one is 0.25, 0.5, 0.75, and then 1. Also notice how it matches up. I want to approximate the solution on 0, 1. So what I'm looking for here is the answer that's going to be in this box that I'm highlighting in green. That's what I'm looking for. Okay. I need to figure out what delta y is going to be equal to. Now it's equal to dy dx times delta x, but in this case my delta x is a 0.25. Now I'm going to write that out as a 1/4. I think I like fractions a little bit better. So this is going to be x over 2. Different from the last problem. And each problem, if you change the delta x, it will change the values that you have. So let's complete this first line. This goes always line by line. Our first coordinate is 0, 0, but I need to calculate delta y, and it's going to be x divided by 2. So 0 divided by 2 is still 0. 0 plus 0 is 0. Now I'll do my new delta y. Delta y is going to be x over 2. So 0.25 divided by 2, or 0.125. So I'm just going to go ahead and add this as a decimal, 0 plus 0.125. So if we look at our graph over here, it's going to go up just a little bit. Then we'll do the next line over here. Our delta y is going to be x over 2, so that's 0.5 over 2, or 0.25. So now notice I have to add my delta y to my previous y value. Okay, because it's going up from this point. Notice where our coordinate point is over here on the right-hand side of our graph. Our x value is moving over. We're adding 0.25, but my y value is going up 1/4. It's going up 0.25. So now it's actually going to be at 0.375. Then we do our next delta y value, so that's 0.75 divided by 2, and that gives me 0.375. This coordinate now is going to go up 0.375, going up just a little bit more, and now it's going to be at 0.75. So the last coordinate point that I have here is 1, 0.75. So the solution using delta x equals to 0.25 is 0.75. And I can say that f of 1 is approximately 0.75 using this method. Let's try a different differential equation. Okay, this time I have y prime equals to 2x plus y. Let's pay attention to our initial condition and where we want to end up. Our first point here is going to be 0, 1. Always look for the initial condition to tell you where your first x and your first y values are. Now the next thing you should do, delta x is 0.25. Fill out the rest of the table for the x's. You can do all of this before you begin. Now I need to figure out my delta y. Delta y is going to equal to dy dx times delta x. So my dy dx is 2x plus y, and my delta x in this problem is equal to 0.25. So if you want to multiply this out, you can, or we'll just go ahead and leave it this way. Let's do this first line first. I need to calculate 2x plus y. So that means 2 times 0 plus 1 times 0.25. So what is that equal to? 2 times 0 is 0. So plus 1, so I simply have 1 plus 1 times 0.25 equals 0.25. So my new y value is 1.25. Now we're going to do the next line. Now notice what our new values are. These are the two numbers we're going to use for x and y. So it's 2 times x, so 2 times 0.25 plus 1.25, and we need to multiply all of that by 0.25. It's a little bit hard to see here, but it's going to be 0.4375, so I need to add that to my new y value. And you know what? I'm going to go ahead and plot this a little bit here. 0, 1, that's my first point. My second point is going to be 0.25, 1.25, so it goes up a little bit. Then now I have 0.5, and I need to add 0.4375 to it. Okay, so this here was 1.6875. Okay, now let's do this next line. We now have 2x plus y, so that's 2 times 0.5 plus our y value, which is 1.6875, and all of that times 0.25. So 2 times 0.5 is 1, 2.6875 times 0.25, and that's going to give us approximately 0.67. Now I'm going to add that to my existing y value, and I'm going to get 2.36. Now I have to do this one more time. 2 times 0.75 plus 2.36, all of that times 0.25. And this is going to equal 0.96. So we take this 0.96, add it to 2.36, and we get 3.32. And that's our answer. Okay, so this stuff right here is going to be part of your homework. You're going to have to do numbers 1 through 7, so everything is on this worksheet. And I'm going to help you guys get started here. We are going to use Euler's method to find the approximation of y equals to 1/2. So for all of these, you're going to look for the same y value. It's when x equals to 1/2. Pay attention to the differential equation because they do change on each of the problems. So notice over here, we have y of 0 equals to 2. So you're going to start with 0, 2. Delta x is 1/4. So the first x value here is 1/4, and the next one is 1/2. Our dy dx in this case is a negative y times dx, so it'll be negative y times 1/4. This first method, or first part of the problem here, is part A, using Euler's method. The second part of this, part B, is to solve the initial value problem. So I want you to separate the variables. Dy dx equals to negative y. Move the y over, integrate and solve. And you have an initial condition, so you're going to calculate the constant. And then you can actually calculate what the actual value is. Once you get this y equals to, I want you to figure out what y of 1/2 is. And then the third part, I want you to calculate a percentage error. That's right here, exact minus approximate over exact times 100%. And then this last part, verify using the calculator program, and I'm going to attach that as a separate video right after I finish this one. You have a few other problems on the back side, numbers 5 through 7. Please pay attention to this one. You are not going to solve the initial value problem here. You are just going to use Euler's method.